Hi guys, good evening. So in the last session, we saw about access control policies. Okay. And under access control policies, we were creating access control rules. And I gave you guys a task. So did you guys complete the task? Yes or no? You will do it today. What about other people? No, will complete tomorrow. Okay. All right. So today let's go with the translation theory. I had an issue with the lab, fixed it, will complete it tonight. Okay, no problem. So today what we have to discuss about is translation. Okay, nobody has done it. No. Translations. So guys, what is translation? What is a translation? NAT. Okay, why it is used? Private IP to public IP and vice versa. What about public to public and private to private? Can I do that? Public to public and private to private? Yes or no? Yes, I think. That is not. Sometimes it is required also. We have a type of NAT which is identity NAT where it is required. Right? Okay. Yes, but mostly used to translate private. Yes, in most cases it will be used for, translation of public to public and private to private only. Sorry, public to private and private to public. This is the most use case. But sometimes it is also used to translate the same IP address into same IP address. Okay. Yeah. So if you want to define translation, you can simply define it that it is used to translate one IP address to another IP address. Okay, one IP address to another IP address. Now, if we talk about types of NAT, so according to Cisco, we have, okay, as per Cisco, we have network address translation, according to Cisco, we have network address translation and we have port address translation. Okay. Guys, I hope you are not getting the background noise. Right now, too much noise is there. It is clear now. Okay. So in the NAT also we have static and dynamic. Okay. And same thing in the PAT also we have static and dynamic. Now, when other vendors are considered, so in case of other vendors, we have two types. That is source NAT and destination NAT. So what is source NAT and what is destination NAT? What is source NAT and what is destination NAT? Okay. What about destination NAT? Destination NAT like PAT. Is it? Is it like PAT? Destination NAT used to access from outside to inside. But how would you define? Outside to inside, I can access using static NAT also, right? For devices which do not understand gateway, that is one implementation. Good. Right. Okay, understand. Basically, what happens that in the source NAT, the translation of source address will be there. Okay. The translation of source address will be there. And in destination NAT, simply translation of your destination address will be there. Okay. Now, in general scenarios, what will happen that your source NAT. So what will come under source NAT? These three things. Your static NAT, dynamic NAT, and dynamic PAT. These will fall under source NAT category, and your destination NAT category will include what? Static PAT. But other than static PAT, when you have non-routable devices in your network, so if you want to access those devices remotely, then also your destination NAT is useful. In the ASA, we have seen this thing, right? If you guys remember, practically also we have seen it. Yeah. So now what are the different types we will see here? So we are going to see whatever the NAT we saw in the ASA, same we will see here also. Static NAT, dynamic NAT, okay, dynamic PAT, static PAT, destination NAT. Then we will see about here also we will have those policies, right? Auto NAT, manual NAT. Okay. Then twice NAT, identity NAT, and twice NAT, this is also known as dual NAT. Identity NAT is known as zero NAT. Okay, so how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I think one is missing. Zero, identity, twice, dual, manual output. Okay. So these are different NAT types that we will see. Some disturbance in voice, echo kind of. Yeah, actually here in the background today, there is some work going on. So that's why. So these all types we will see. So in this configurational part will be the, okay, one NAT I was missing is policy NAT. Okay. So configuration wise, we will see all these things, and these are just the terms that we need to understand. Okay. Like when we will configure policy NAT, automatically we will understand manual NAT, twice NAT, identity NAT, dual NAT, zero NAT, all these things we will understand. Okay. So configuration wise, what we have to see is these 6 different types. Okay, these are the different implementations that we have to see. Okay. Now tell me, what is static NAT? What is static NAT? One-to-one mapping. Okay. Then that's it. Fixed IP. Good. Mapping is done manually. It is bidirectional. Yeah, good. So these all points are to remember only that. First of all, when we talk about static NAT. So in static NAT, we will see one fixed private IP address is mapped with a fixed public IP address. Okay. So here we have one-to-one mapping, and this mapping is done manually. Okay, this mapping is done manually. And here what will happen, that your static NAT, it is bidirectional. Okay. Now what do bidirectional means? Here, what do you mean by bidirectional? What do you mean by bidirectional? Translating both incoming and outgoing traffic. Is it? This is not a correct explanation. You cannot say, right, that it's translating both incoming and outgoing, because there are 2 actions happening actually. Okay. Whenever you perform translation, there are 2 different actions happening. One is translation and second is untranslation. Okay. These 2 actions are happening. So we cannot say, right, that both incoming and outgoing traffic is translated. You can say that from inside to outside when we are going, that time what happens that you're using the public IP. But if somebody is coming from outside and trying to connect to that public IP, so in that case, also they will be able to communicate. Okay, like what we are trying to say here is, let me open the lab. Okay. So here, what we are trying to say is, with the help of bidirectional, that if I'm translating, okay, but if I'm translating this IP address, and when this IP address goes outside, okay, when it is trying to go outside, so let's say it should be translated to something like, consider it 100.111. Okay, so that means when this message will arrive at this router, so the who will be the source? The source IP will be, what will be the source IP? 100.1.1.1. Same way, this guy can also initiate the traffic. Okay, that means anybody from the outside. Consider this guy wants to communicate here. Okay, so when this guy will generate the traffic, so he will use the destination as what? 100.1.1 as the destination. And with the help of this address, he will be able to communicate with this router. Is it clear? So when the traffic is going from inside to outside, that time translation is happening. And when the traffic is initiated from outside, then untranslation will be there. Okay. Clear? So we cannot say that it's translating both incoming and outgoing. No. Okay. There is a slight difference. Okay. All right. So that means simply you can say that with the help of public IP, you can have two-way communication. You can communicate with anybody and anybody can communicate with you using that public IP only. That means bidirectional. Now, why it is used? Where your static NAT will be used? Can I use it for my clients? Yes or no? Can we use static NAT for clients? No. Why? Why we cannot use it for clients? Because for servers we mostly use. Why we don't use it for clients? Expansive. Okay, because see here one IP address is mapped with another IP address, correct? And the mapping is 1-to-1 and it is fixed. So if you try to use it for clients, then the number of public IP addresses that you're going to require is going to be very huge. Okay, the organization has to purchase multiple IP addresses. So if you have 100 clients, then the organization has to purchase 100 IP addresses. And that will be what? Expansive. So we don't use it for clients. We use it for servers. Okay. So you will say mostly used for servers like website. Okay. Then if we talk about dynamic net, what about dynamic net? What about dynamic net? Using pool of address. Okay. What else? Act like one direction. That means unidirectional. Okay. So it's exactly kind of similar to your static net only, but the mapping is being done automatically. Number of private IP address are translated to pool of public IP address. Correct. Okay. So you'll say that a number of private IP addresses are translated to a pool of public IP addresses. Okay. And here also we have 1 to 1 mapping only, but the mapping will be done automatically. Okay. This is expansive. As organization has to purchase multiple IP, multiple public IP addresses to create a pool. Correct. Okay. The IP addresses from the pool will be assigned randomly. Okay. Will be assigned randomly from the pool based on first come, first services. Okay, whomsoever will come first will get an IP address. Whomsoever is coming at the last might not get the IP address depending on the address availability. Okay, so that means in your pool, if you have 2 addresses, 5 addresses, so only that many systems will be able to access the internet. Okay, remaining, let's say, for example, if you have 2 IP addresses in the pool, so only 2 systems will be able to access the internet. Okay, system number 3 will not be able to access the internet. Why? Because there is no free IP in the pool. Okay, and anyone who is coming first will get an IP address. Anyone who is coming last might not get an IP address. And since here the mapping is done automatically, 1 to 1 mapping is there, but this is a dynamic process. Okay, that means the IP address are like they are not fixed. The public IP addresses that are being assigned, they are not fixed. Anybody can get the same IP address later. Okay, so for that reason, this is not bidirectional, it is unidirectional. This is what? Unidirectional. This is clear. Okay. Then we have dynamic path. Now, what is dynamic path? What is dynamic path? Yes, please. Using one public IP and each session identified through port number, private IP address are translated to single public IP address. Okay. So here, a number of private IP addresses are translated to a single public IP address. Okay. The traffic before that approx. How many addresses we can translate approx? Two 54. No, not 254. Yes. Okay. Approximately 64K address. That means 64,000 addresses. So approx 64K addresses can be translated to a single public IP address. Okay. Now why 64K? Because here translation of port numbers, okay, and the traffic is segregated based on port numbers. So is everybody aware how the traffic is segregated based on port numbers? Yes or no? Yes. Okay, no. Okay, what about Bashir and Gautam? No. Yes. Okay, two yes and two no's. Okay, so no problem. Let me explain. How does it happen? Okay. So consider this is our lab. Now we have performed what? Dynamic part, that is port address translation. Now, according to port address translation, what will happen that this IP address, whatever is your inside IP address, will get translated to a specific IP address on the outside. Okay, so either it can be your outside interface IP address or you can use a static IP also, totally fine. So let's consider that this is getting translated to a fixed IP address, which is like, 200.1.1.1. This is the IP address to which it is getting translated. Okay. Now, when this inside R1 will generate a packet, so in the message there will be source IP, destination IP, source port, and destination port. Source IP will be 10.125. Destination will be 11.125. What will be the source port value? What will be the source port value? Random. So let's consider it. The port number is 1234. And destination port number, let's say you are taking telnet access. So this will be 23. Okay. Now this message will go from here to your FTD. And in the FTD, you have configured a translation. Okay. In the FTD, what you have configured is you have configured a translation engine. What is the translation you have configured? That the network 10.110/24 should get translated to 200.111. Okay. This is how the translation should happen. So now what? When this guy will try to go outside, your FTD will match the translation and we'll see that, okay, 10.110/24 should be translated to 200.111. So what your FTD will do here in this message, FTD will translate the source IP address. And this will be translated to something like 200.1. And once the translation is done, your FTD will make an entry in the XLATE table. Okay, here let's consider XLATE table. In the XLATE table, your FTD will make an entry that I have translated 10.111/125 to 200.111. This is how the translation has been done. Okay. And then your FTD will send this message where? To the outside R1. Then after, at the same time, let's say your inside R2 is also trying to communicate. So inside R2 will say, this will say source IP, destination IP, source port, destination port, source IP will be 10.126, destination IP will be, let's say 11.125, source port will be anything this guy can use. Let's consider this guy is also using 1234 and destination port number 23. This guy is also taking a telnet access. Now this message, once this message will come to the FTD, FTD will check the translation that it has to translate 10.110/24 to 200.111. So what your FTD will do here? FTD will modify this address into 200.1. Then it will forward it here to the outside R2 or the outside R1. Okay. Now when outside R1 will respond to this traffic, so the response of this first message will be what? Here, source IP, destination IP, source port, destination port. Source IP will be 11.125, destination will be 200.1, source port will be 23, destination port will be 1234. Okay. And while the FTD translated this address, okay, while the FTD translated this address into 200.111, FTD will also make one entry here in the XLATE that I have translated 10.126 into 200.1.1. Okay. Okay, this entry it will make. So when the response of this traffic will be generated, the response of this traffic will be source IP, destination IP, source port, destination port. Source IP will be 11.125. Destination IP will be 200.1. Source port will be 23. Destination port will be 1234. Okay, this will be the reply. Now these two replies will come to the FTD. These two replies will come to the FTD, right? These two replies will come to the FTD. This will also come to the FTD. FTD will see that what is the destination IP address 200.111, 200.111. So when FTD will check the XLATE table, it will see that, okay, now I have translated two addresses into same address. Now which response is for which PC? Yes, both source IP same, doesn't matter. FTD will check the destination because FTD has the entry only for this thing, right? 200.111. So FTD will see here that, okay, this is also 200.111, this is also 200.111. Now, which reply is for which PC? Is it for inside R1 or is it for inside R2? Not sure. Problem is there, right? So to avoid this kind of confusion, what FTD will do here? Okay. What your FTD is going to do in this case, see here. When this message will come from inside to outside, and it will have source IP as 10.1.125. What your FTD will do, it will translate it. Okay. But also after the translation, it will make note of the port number. That source port number was 1234. So what your FTD will do here, it will make an entry of port number. Okay. FTD will make an entry of port number before translation. Okay. And with the same port number, there is no translation happening. Okay. So after the translation also, it will use the same port number because there is no entry available already with this port number. Okay. And then after what your FTD will do, FTD will forward it here. Same way when this response will come from 11.111.126 to the FTD. What FTD will do? FTD will make this entry, but also it will note down the port number. Now FTD will say, this guy also came up with the same port number. Okay, but the problem is I cannot translate 200, like I cannot translate this address to 200.111 using the same port number. So after the translation, what your FTD will do? Here, FTD will change the port number. Let's say it will make it something like, you can consider it like 1024, you can consider. So that means when this message will go after translation, this port number will be what? This port number will be 1024. This port number will be 1024. Okay. And then this message will go to the outside R1. Okay. So when outside R1 will respond in the destination, what is the port number it is going to use? Here, it will use this port number. Okay. It will use this 1024 port number. So the response will come to this port number. Now what will happen? See here. When the responses will come to the FTD, this is coming to the FTD and also this response is coming to the FTD. Now FTD will look where? It will look at the destination IP as well as the destination port number. So the traffic is coming for 200.111, port number 1234. 200.111, port number 1234. So that means we have to untranslate this address back to 10.111.125, port number 1234. So what your FTD will do here? We'll remove this IP address and we'll say this is for 10.125. Okay. And then after, FTD will forward this traffic to the inside R1. Okay. And when this traffic will come, 200.111 port number 1024, 200.111 port number 1024. So untranslated back to 10.111.126 port number 1234. So FTD will change these two criteria. FTD will say that this is 10.126 with port number 1234. And then FTD will forward it. Yeah. Understood? So this is how your traffic will be segregated based on port numbers. Our browser works on PAT. No, it's not the browser. These translations, these are performed by your edge device, like your Wi-Fi routers. Okay. Yeah. So in our home networks, whatever the Wi-Fi router we are using, so those Wi-Fi routers, they are having this port address translation concept configured. Okay. This is clear to everyone? Okay. Now here we have two different kinds of tables. Okay. Whenever we talk about translation, so we have two tables here. One is NAT table, and second one is XLATE table. What is the difference between NAT table and XLATE table? What is the difference? NAT table contains the configuration. What about XLATE? What about XLATE table? XLATE will maintain the translation or connection information or actual translation. Correct. Okay. So simply you can say that NAT table will have the information about what you have configured. Okay. So this will contain what? Configuration. And in simple words, if we see, this will contain your actual translation. Okay. So if you want to understand it according to one example, so we see here. This was our lab, right? So this information, what we configured, right? This information will be there in the NAT table. This one, that we are translating this network into this one. So this information will be there in the NAT table, and this is the XLATE table information that, okay, which IP address is exactly getting translated to which particular IP and port. Okay. This is clear about the NAT table and XLATE table. Okay. Then we have static PAT. What is static PAT? What is static PAT? What is static fact? Particular IP with a particular port. Okay. So simply, we can understand it with this kind of example because you guys are already taking the remote access, right, of the labs. So this example will make it easier. Now, instead of considering it as inside R1 and considering this one as inside R2, let's consider it as this is CCNP rack, okay, and this is CCIE rack. Okay, and these are the IP addresses, and these are the servers which are running at port number 80. These are running what? Port number 80. And this is one public IP address that I have purchased from the ISP. Okay, this is static public IP address that I have purchased from the ISP. Okay, now this IP address I will configure where? On this interface. Okay, I have configured. Now what? Let's say these are like, this is not outside R1. Let's consider this as CCNP student. Okay. And this one, let's consider that as CCIE student. Now what will happen? We want to give what? Remote access to these students. Okay. Now for every single student, I'm not going to purchase an individual IP address. So what I'll do, I will use this single address and I will map these two racks. How I will map? Now they're having the same IP, I mean, they are running the same port 80. IP addresses are different. Okay, and I want to use the single IP address only. So what I'll do, I'll make a translation something like this, that 10.1.1.25 port number 80 should be translated to 200.1.1.1. Okay, and let's say port number 8080. This kind of port number I want to use. Okay, this kind of port number I have used. And for the second lab, I have said that 10.1.1.126 port number 80 should be translated to 200.1.1.1 port number 6178. Okay, now what? To the CCNP students, I will say that you use this IP address along with this port number. So what these students will do, they will take RDP or they will take, website access or the, EVNG access if you want to talk about. So they will use the, so this is not source here. Change it. So now when CCNP students want to access, I'll give them with the public IP 200.1.1 and with the port number 8080. Okay, like your FTD lab is what? Port number 6178, right? Correct? When you are accessing the FTD lab, it should be port number 6178. Am I right? Yeah. So this is the same thing here, that actually our services are not running on port number 6178. Okay, if you are taking RDP, what is the RDP port number? What is the RDP port number? Double 389, correct. Okay, but you are accessing using what? Port number 6178. So this is how it is mapped, right? So when you generate the traffic will be what? The traffic will be like this. That source IP is 11.125, destination IP 200.1, source port number, anything random they can use, and destination port number they are using like 8080. This is for the CCNP students. Okay. Now when this traffic will come to the FTD, this traffic will come to the FTD, and what FTD will do? FTD will look at the translations, that 200.111, and port number is what? 8080. So we have to change it. So port number, destination port number will become 80. And this IP address after translation will become 10.125. And this is how they will access what? The CCNP. And same way, the CCIE students, okay, they will say source IP 11. Let's say 126, destination IP 200.1, source port they will use random, and destination port, let's say they will use 6178. Now this traffic will come to the FTD. FTD will look at the translations. Now FTD will check this port number has to be changed to 80, and this IP address has to be changed to 10.126. Okay, so this is what 10.126, and destination port number is what? 80. And this is how they will get the access. And in the similar way, you are getting the access. I have not used the FTD lab, but I have seen it when I was using a local server. Yes, correct. Okay, so that is just this port forwarding only. That your services are not running on the, like your services are not running on this port, but you're just forwarding this traffic to some other port where your actually service is running. Okay. Yeah, correct. So this is clear, your static PAT concept. Okay. Now next is what? Policy net. Okay. So what is policy net is about? Let's say this is your Delhi branch. Okay. And this one is your Pune branch. Okay. And this branch, this side, we have the Bangalore branch. Okay. So let's change their names again. Okay. So one is Delhi branch, another one is Pune branch. Now what I want to do is I want to access from my Bangalore branch network to the Delhi branch. And same way from the Bangalore branch, I want to access the Pune branch also. Okay. But what I'm willing to do is I'm not willing to use the same IP address. Okay, or else you can consider it in this way, that what they have done is, in the Delhi branch they have a firewall, but firewall is blocking all the outside to inside traffic. Okay, firewall has blocked all the outside to inside traffic. So now you want to access, so you have asked them to explicitly allow one IP address, that is their IP address. Okay, so here let's say they have allowed one IP address. Okay, here they have allowed one IP address, which is 13.1.1.1. And Pune branch, they have allowed one IP address 14.1.1.1. Okay. So according to PolicyNet, what happens that depending on the destination you are going, your translation will occur. Okay, your translation will not be according to the source. That means you will translate the source address only, but your translation will depend that, okay, which destination you are going. So depending on your destination, your translation will be there. Okay, so in the FTD, we will configure something like, what we are going to configure here is, okay, we will say that, okay, I'm just explaining it like an English sentence, and practical implementation we will understand when we do it. So you will say if source equals to, okay, or let's say something like if destination equals to Delhi, in that case, translate 10110/24 to 13111. Okay. And you will say if destination equals to Pune, in that case, translate same 10110/24 to 14.1. This kind of translation will be there. Now, doesn't matter who is accessing. If they are going to Delhi branch, automatically their translation will happen to this address 13111. If they are going to Pune branch, their translation will happen for 14.1. This is conditional. Here we will define a policy. Yes. Okay. Here we are giving a condition. Okay. So based on the condition, based on your destination. So this is the policy we are defining, right? That if destination is Delhi, then only translate to this address. If destination is Pune, then only translate to 14.1.1. Okay. This is what your policy NAT is. Clear? All right. So we have seen static, dynamic path, static path. Now policy NAT also we have seen. Now let's talk about destination NAT. Okay. So understand it. This is outside R1. Now destination NAT. In your network, okay. In your network, if you have non-routable devices. Now what are non-routable devices? What are non-routable devices? Printers, security cameras, etc. Correct. So the devices which are not having the gateway capability, where you cannot provide default gateway. Okay, so in that case, so for example, right now when we are using this inside R1 and inside R2, so what I'm doing is I'm using a default gateway or a default route on these towards the FTD. And because of that, I'm able to communicate here with the outside R1 as well as the outside R2, correct? Because I'm using a default route on the inside R2. And I'm giving my next hop address as my FTD, correct? Imagine I don't have the, like if there is no default route, I don't have the default route. Can I communicate with the outside? If I don't have a default route, can I communicate? No, correct? So what I'll do is I'll perform NAT here, and with the help of NAT, I will provide communication. Okay. So first of all, I want that, okay, this should be accessible from outside. So from outside, if anybody wants to access this IP, so what I'll do, I'll perform a static NAT. Okay. And in the static NAT, I'll give one entry here that 10.1.126 should be translated to, let's say, for example, 200.111. Now this is static translation. So that means now the outside R1 or outside R2, they can use this IP address to communicate with this. Yes or no? They can do it. So that means my request will now come from here to the FTD. FTD will see this translation, will translate it. I mean, will untranslate it to 10.1.126. My request message will come to the inside R2. Yes or no? So now, what about the reply? What about the reply? My reply will pass or not pass, where it will drop. Where my reply message is going to drop. Not process. Okay, so where it will drop? Where my reply message is going to drop? Inside R2. Why? Because my inside R2 is not having what? It's not having the default route here. So that means it cannot communicate with a different network. Okay. And since it cannot communicate with a different network, so it will not be able to communicate. Okay. It will not be able to communicate. It will drop the message. So what we'll do? See, this 10.1.126, your inside R2 cannot communicate with a different network. But what about if it is same network? Like if your inside R2 wants to communicate with inside R1, does it require any gateway? No, right? So what I'll do is I'll say that I also want to translate. Okay. I want to translate your 11.1.1.125 to 10.1.1, let's say 25. If I will perform this translation, now what will happen? Understand. When I will generate a message from here, okay. So my message will look like, now I will not communicate with 10.1.1.126, I'll communicate with 200.1.1. Okay. So I will have the information like source IP, destination IP, source port, destination port. Source IP will be 11.125, destination IP will be 200.1, source port will be, let's say 123, and destination port will be, let's say 80 or you are taking telnet, consider it 23. Okay. Now, if something like this is there, message will come to the FTD. FTD will check the translation. Now, 200.111 will get translated to 10.126. Okay. And 11.111.125 will get translated to 10.25. Now, this message will come where? To the inside R2. Now, inside R2 will respond, right? So, source will become destination, destination will become source. Okay. So, this will become 126. This will become 25. This will be 23. This will be 1%. So now tell me, can the inside R2 send the message or not? Yes or no? This message will be forwarded or not? Now this is the same network, right? Broadcast. Why broadcast? This message will be definitely forwarded. It's in the same network. Okay. And what your inside R2 will do? It will generate an ARP to get the MAC address. When your inside R2 will generate an ARP to get the MAC address, your FTD will act as a proxy. Will give its own MAC address. So that means automatically the message will come back to FTD. Okay. So what FTD will do? Now FTD will perform what? Translation and translation. And this will get translated. 10.111.125 will get untranslated to 11.125. And this response message, now it will come here. So this is how your non-routable devices also can communicate with the help of destination map. Clear? It's clear, right? Okay. So this was the theoretical part about all these things. Practical implementation, we are going to see on Mondays. Okay. So if you have any doubt in this part, you guys can ask. So then we'll wind up for today, guys. Okay. We'll see the practical implementation of the NAC on Mondays. Okay. Okay, guys, that's it for the day. I'll see you guys on Monday.